Hello, this is a demo for KubeAid Bootstrap Script support for the Azure cloud provider. And this demo is specifically meant for the Blackwood 7 team because because the Blackwood 7 team, they tried using it a few months back. It didn't go well. We took the feedback and improved on those. So I'm going to speak about those improvements as well, so the BW7 team can relate to it, right? All right, so I have written up guide documentations for each cloud provider that we support. We haven't hosted the documentation anywhere, so for now you need to go to KubeAid Bootstrap Script GitHub repository, and then this is a path. So here you can read the documentation, the guide documentation for Azure support, right? I have opened this up in my local terminal just so it's easy for me to highlight different parts of it as I go through it, right? So the agenda for this demo is first to bootstrap a cluster. It will be a self-managed cluster in Azure, right? I will discuss about the features that we promise to deliver. Then we will upgrade the cluster, so we will do a Kubernetes version upgrade. If you want, you can also do OS upgrade, but I'm not going to show that here. After we do the upgrade, we are going to scrape off the cluster and then recover it from the backups done by Velero, right? So that's more or less the things that I want to showcase. Let's go through the features real quick that we promise to deliver. So the bootstrapped cluster will be running Cilium CNI in kubeproxyless mode, so it will use eBPF. The script will install required CSI drivers and CCM in the cluster. We will also do Azure workload identity setup for you. So if I try to relate this with AWS, in AWS, BW7 currently uses Kube2 IAM, which intercepts pod network traffic and then injects correct IAM credentials in there. The next iteration of Kube2 IAM is IRSA, which is officially released by AWS. There's a nice blog about it. And I think there has been some discussion about AWS IRSA in BW7, but yeah, there's an issue created, but we haven't started working on it, so it's on pending. AWS workload identity is similar to AWS IRSA. So the concept is that before we had Azure pod identity, if we remember correctly, which is similar to Kube2 IAM. It intercepts pod network traffic and injects proper Azure Active Directory credentials into the network traffic, right? When you use Azure Workload Identity, your pod can exchange their service account tokens for Azure Active Directory tokens by directly speaking with Azure Active Directory, right? So there is no network traffic interception. And then they can use that Active Directory token to communicate directly with other Azure APIs. So we will set this up for you. Next we have auto-scalable node groups with scale to or from 0 support and labels and taints propagation, just like it is in KOPS. We do everything using GitHubs, so Registry and Sealed Secrets are there, but we also have ClusterAPI to manage your cluster in a GitHub's native way, and also CrossPlane to provision all the required infrastructure in a GitHub's native way, right? We do monitoring setup using kubeprometheus and disaster recovery setup using Velero. Now, just a small thing, I'm going to skip kubeprometheus installation because the Kubernetes build time takes it's high, and yeah, it's going to be some extra workload which I don't want, so I'm just going to skip this part for the demo, right? So it will save us some time. So these are the features that we will deliver. We need to finish some prerequisites. So the first thing is you need to fork the KubeAid config repository. You need to have your Git provider credentials ready. So I'm assuming you guys are using GitHub, and you need to have your GitHub username and personal access token. This is the permission required for the path. So the path should be able to write to your KubeAid config fork, right? You should have Docker running locally on your system. This is because what we will do is first provision a local K3D based management cluster, put ClusterAPI and CrossPlane there, and then use them to provision all the infrastructure and the main cluster in Azure, right? Next, you need to create a Microsoft Enterprise application. So you can go to your Azure dashboard and you will see Enterprise applications here. Click on that, and yeah, you can create a new application from here, right? I have already done that to save some time. So this is the Enterprise application, and when you create one, Azure behind the scenes will create a service principal for that Enterprise application. So service principal is kind of like a security entity that represents the Enterprise application, right? If we search KubeAid demo here, yeah, so you will see two results. One is the Enterprise application, and one is the service principal that gets created by Azure. So have these two open because we need details from here to fill up the config files later, right? Once we are done with that, we need two SSH key pairs, one in OpenSSH format. So this one will be used to SSH into the VMs, and the other one in PEM format. This will be used for the Azure workload identity setup. Lastly, you need to have some runtime dependencies installed in your system. Now, if you remember properly, previously we used to distribute KubeAid Bootstrap Script container images because there were a lot of runtime dependencies, and we have put our effort to decrease the number of runtime dependencies as much as possible. So the ones we have currently are these. And for Obmondo users, you should have most of them already installed on your system. So these ones, for example, are to build Kubernetes. You should already have these in your system. kubectl is there in almost any developer system who is dealing with Kubernetes. Another one is kubectl. This one you might need to install by yourself, clusterCTL, and also K3D, right? So these are the runtime dependencies. We provide a bash script which you can wget and then run to install all of these. Like, it will install only those which are not already present in your system. Or if you want, you can install these using whatever package management solution you use. So in Mac, if you're using Homebrew, you can use that, or you can use Pacman in Arch. I, for example, use Nix, so I use Nix to get all of these dependencies, right? So it's up to you which solution you choose. If you want to go the easy way, you can just run our script. So these are the dependencies. Yeah, so the point I was trying to make, by the way, here is that we now provide the bare binary itself. You can just wget the binary from our GitHub releases page, and you can directly run that on your host system. You just need to make sure these runtime dependencies are already installed in your system. If any of these are not installed, when you run the script, it will prompt to you that this runtime dependency is not available. Please install it and then rerun the script. Yeah, so once you're done with all of these prerequisites, we can move ahead to the next section, which is preparing the configuration files. So previously we used to provide only one single configuration file where you mentioned your non-secret configurations and also the credentials. We have changed the UX a little bit, so now we have two configuration files. One is general.yaml, where you specify your non-secret configurations, and then we also have secrets.yaml file, where you mention your Git provider and cloud provider credentials, right? So this is the command that you can run to generate sample config files, right? So I'm going to do that. Before doing that, just a small reminder, I also need to add it in the documentation, which is that I'm currently on a Mac, right? Let me just close this. So I'm currently on a Mac. This has 8 GB of RAM, and 4 GB is allocated to Docker Desktop. Now the thing is, 4 GB is not really enough to run the script. I have tried running it on Mac with 4 GB RAM allocated for all the Docker containers, but many pods I have seen get killed. Like, some of the pods get killed due to out of memory issue, and the system starts to get like hangy a bit. So we recommend you using a machine which at least has 16 GB of memory. And what I have done is I have SSH'd into my Linux laptop that is provided by my office. This has 16, if not 32 GB of memory, right? So we will run the script here, and yeah, as you can see, I have already downloaded the binary here locally. So I'll run this command and generate the sample config files. Yeah, so this is a general.yaml file which you need to fill up, and you can see most of the configuration fields are fairly documented, except the most obvious ones. For example, this one, the field names are itself pretty descriptive, so I haven't put any doc comments here. But for example, you can take a look at this one, the storage account name, which needs to be created for storing the backups and also for the workload identity setup. So I have put relevant information in the doc comments. You can go through these and incrementally fill up the configuration files, right? This is the secrets.yaml file where you should have your Git provider and cloud provider credentials. Now I have already filled up these configuration files ahead of time, so I'm just going to copy that here. Yeah, so this is the filled up general.yaml file. I'm not going to open the secrets.yaml file because it contains my credentials. These are the two SSH key pairs which I have generated. So this one is for SSHing into the VMs, and this one is for the workload identity setup. And also, so as I mentioned, I'm using Nix to manage my dependencies, the runtime dependencies. I'm not currently in a Nix shell, so the dependencies are not currently available in this shell environment. Let's try to run the script. Let's try to bootstrap the cluster. So yeah, this is the command, cluster bootstrap. And I'm going to use these two flags. So what you can do is you can use the --help flag, and it will show you all the available CLI flags, and what each flag is meant for. So I'm using this one, skip monitoring setup, because as I told, I want to use I want to skip the Kubernetes installation to save time, and also skip PR workflow. So by default, KubeAid Bootstrap Script will create PRs instead of pushing directly to the default branch. Just to save time, I'm going to skip this PR workflow and let KubeAid Bootstrap Script push changes directly to the main or the default branch, basically. So I'm going to run this command, trying to bootstrap a cluster locally. Yeah, so it prompted me that the runtime dependency is not available, right? I should iterate on this and report all the runtime dependencies at once that are not available. For now, it just reports one and then exits. So I'm going to copy my flake.nix file here. So it will drop me into a Nix shell which has the dependencies available, right? So if we check out the Nix flake file, so I have specified that these are the runtime dependencies that I require. So you can see JSON.NET is available, and all the other runtime dependencies are available as well. Now let's retry bootstrapping the cluster, and it should work. Yeah, so as you can see, it's creating the local K3D based management cluster. By the way, we have done a small improvement here, which is that if you remember last time, every time the K3D management cluster got spun up, you had to pull all the container images locally in the K3D container registry, right? And it used to happen every time. And because of this, the whole process was pretty time consuming. Especially Argo CD installation, because the Argo CD images are pretty big and it used to take good amounts of time to pull all the container images. Here, if you see, it takes just 1 minute or maybe a little bit less than that. It is because I have the images already pulled locally. So when you run the script, for the first time, definitely it will pull all the images, but it will save those images locally. So if I do docker image ls argo, and yeah, so you can see the Argo CD images already pulled. It's the same for the CrossPlane components or the ClusterAPI components, right? So after the first time, the image like the script running time will be less because of this, because you don't need to pull the container images every time. And also another thing is sometimes, like rarely, it shouldn't happen, but it's a non-zero probability that the script might error out when trying to sync an Argo CD app. Okay, shouldn't happen generally, but there is still a non-zero probability for that. And in that case, you can just rerun this command, because the whole process is idempotent, right? So if you rerun, then it will detect that the management cluster already exists, so it will skip that. It will detect which Helm charts are already installed and it will skip reinstalling those Helm charts. It will also pick up existing infrastructure, so the whole process is basically idempotent, and you can keep rerunning the script, right? So here we can see that it's installing CrossPlane and then trying to provision infrastructure for workload identity setup and disaster recovery setup in Azure, right? So I'll try to open the management cluster in K9s, and let's see what's going on there. Alright, so all the CrossPlane components are installed. Yeah, so infrastructure is getting created. We should have a new resource group here. Right, so our infrastructure creation is complete, and the script is now doing the script is now installing all the required components of ClusterAPI. And as you can see, it's quite a lot of pods, including the ClusterAPI and CrossPlane components. And this is why we want a machine which has like 16 gigabytes of RAM. With 16 gigabytes, it should run fine, like should do good. So this is the infrastructure provider, ClusterAPI. ClusterAPI's infrastructure provider component. It's called CAPC. So this and this are responsible for provisioning your main cluster. Yeah, so we need to wait for some time because this cluster provisioning takes quite good amount of time, like around 20 minutes. And I cannot do anything in this because the infrastructure creation time for Azure is quite high compared to AWS. You will see people complaining about this, but especially the VMs, they take good amount of time to be created. So yeah, we need to, I'm just gonna leave this like as it is here for around 20 minutes. So I'll be back after 20 minutes when the cluster is provisioned. Alright, so the main cluster has been provisioned. As you can see, it almost took like 20 minutes. The script has nothing to do with this. This is solely the infrastructure creation time, especially creation of the VMs, which takes a good amount of time. By the way, a note is that if you remember, in case of AWS, we had to build custom AMIs. When we started working on the Azure support, at that time we also had to build custom machine images for these Azure Kubernetes nodes, but we scraped it off to make the UX simpler. So we don't need any custom machine images. We just use Ubuntu, but the node startup time is a little bit high because of that. Because when a node starts up, it doesn't have all the tools already pre-installed, so it installs containerd and the CNI plugins and whatever others are required. So the node startup time is a little bit high, but in the cost of like making the UX a little bit simpler. So you don't need to maintain custom machine images for every Kubernetes version. Cluster is provisioned. It's just waiting for the Kubernetes API server to be reachable, and we need at least one worker node to be initialized so we can deploy our application workloads like Argo CD, Cert Manager, and other stuff. for some reason, syncing of ClusterAPI operator takes quite a long time. I don't know why, because if you check for the management cluster, it was pretty quick. Yeah, so it was very quick, but I noticed this started happening recently, that the syncing of the ClusterAPI operator takes a good amount of time, and it seems that the CRDs are out of sync, and then it takes a good amount of time for them to get into sync. Right, so the main cluster is set up, and you can just copy paste these commands if you wish to access the Argo CD dashboard, just like I did basically. Alright, it seems like I need to increase the memory of Argo CD application controller, because it gets OOM killed. This is with the new version of Argo CD that this started happening. All right, so yeah, the cluster bootstrap process finally finished. All of the Argo CD apps are synced. It also triggered the first Velero backup and the first Sealed Secrets backup. So we can go ahead and take a look at, yeah, so Sealed Secrets backup, it completed. And we can take a look at Velero as well. Hopefully it's running properly, yeah. Right, so we can go and take a look at the storage account, whether the backups are uploaded or not. Yeah, so this is the Sealed Secrets backup, and yeah, so this is a Velero backup basically. One thing to note is that we use the same storage account for hosting the OIDC provider for workload identity purposes, and also to store the backups. Now, if I remember correctly, I think you can set the tier, like storage tier of each blob container. So these backup ones, you can set to cold, and this one can be hot because it's going to be used pretty often. I currently don't do that, but sure, I can make the change in CrossPlane compositions, so these two are in the cold tier by default, so we can do some cost savings, right? So the cluster has been bootstrapped, our first backups have been taken, so this process is complete. Now what I'm going to do is we are going to do a Kubernetes version upgrade.